Okay, let's look at an example in the book. It's example 2.1, and we have a bolt with two forces acting on it, with force Q at 60 newtons at some angle, and force P with 40 newtons at some angle. So we want to find the resultant force, or what is the equivalent single force acting on this bolt. Okay, so the first pass, let's do this graphically. Now, honestly, this is not the most helpful thing, but it's a good exercise, but it's not really a useful solution in the real world. So how do we do it graphically? Well, let's start here. Let's draw a trapezoid, right? We have our trapezoid. So this is supposed to be my effort to draw equal and parallel to Q, and that is my equal and parallel to P, and therefore you go from here to there, and that is my force. This is my R. Okay, so this angle, what is this angle? Well, that angle, I don't know, it's going to be greater than 20 and less than, say, 45. So it's going to be somewhere between 20 and 45. Should we call it around, I don't know, 35 to 40, somewhere around there? And then what is this distance from here to here? This magnitude? Well, if it got ended, if they're in a straight line, it'd be 60 plus 40 would be 100. So it's a little bit less than 100. So we call it like, so say around 95. So we're going to say that our resultant R is around 95 and at an angle of around, say, 35 to 40 degrees. Okay, so that's reasonable. Depends on what you're looking for, but you're not going to use that to do any serious analysis, but it gives you a ballpark. So let's look at the other way. How's the other way to do it? Well, let's use the trigonometric solution. So how do you do that? Well, again, we have to let's draw this out. This is P, and that's 40 newtons, right? And then you have, oh, see if I can bring this back down. And this is Q, and that is 60 newtons, right? So this angle right here is 20 degrees. This angle here is defined as 25 degrees. So our resultant is going to be here. That's R. And we need to know the magnitude and the angle. Well, we know this angle, right? That angle all the way over to here is 180. So subtract off that 25, and that is 155 degrees. So let's use the law of cosines to determine what the magnitude of R is. So what is that? We have R squared is equal to P squared plus Q squared minus 2PQ cosine of theta, right? So it's equal to 40 squared plus 60 squared minus 2 times 40 times 60 cosine of 155. So it turns out that R is equal to about 97.7. Okay, so now we know the magnitude. This is 97.7. And now we need to find this angle, actually this angle here, which we'll call alpha. Well, we can't find that directly, but we can use a lot of sines to find this angle. We'll call that A. So what is the law of sines? It's sine of A over A is equal to sine of B over B equals sine C over C. So we know this one. We know the magnitude of R, we know the magnitude of P and Q, and we know that angle. So let's say sine of A over the opposite of that is 60, right? Is equal to sine of B, what we're going to call it 155 over 97.7, and that gives us that A is equal to 15.04. But we don't want A, we want alpha, and so alpha, really, go, stop. Alpha is A plus 20 degrees, so therefore alpha is 35.04 degrees. So our resultant is 97.7 newtons at an angle of 35.04 degrees. And that is our answer.